find the equation of the tangent line of the function, the given point, and then approximate the function using the tangent line at the second point. So for the first one, I'm going to use f of x equal to 3 raised to the x squared minus x. I want the tangent line at 1, 1, and I want to approximate at f 1.1. First, we'll just check to make sure this point is on the graph of f. So I put in 1. That gives me 3 to the 1 squared minus 1. Gives me 3 to the 0, and that's equal to 1. Do the derivative. Now notice, I'd rather rewrite 3 as e to the natural log of 3. That makes what's happening here much clearer to see when I take the derivative. Note, e to the natural log of 3 is going to be 3 because e to the x and natural log of x are inverse functions. So if I put one inside the other, x comes out. In this case, the x is going to be 3. When I take the derivative of this, the rule for the derivative of e to the u is just rewrite your e to the u and then take the derivative of u. So that's going to give me, I rewrite, that's just my e to the u. Derivative of u is going to be natural log of 3, which is a constant. Okay, it looks intimidating, but it's just a number, so we can just forget about it when we take the derivative. Just carry it along. Derivative of x squared minus x is 2x minus 1. I put in 1 to get an actual number for the slope of the tangent line. So let's see what happens here. Well, if we put 1 into this, that's going to give me a 0. So I have e to the 0. Natural log of 3 sticks around. And then 2 to the x minus 1 becomes 1. So I'm left with natural log of 3 for the slope of the tangent line. And now putting it into the equation of a line, I have y minus 1 equals natural log of 3, x minus 1. And natural log of 3 is roughly 1.099. So that's my tangent line. Let's approximate using the tangent line. So we want to know what happens when we look at 1.1 instead of 1. If I put 1.1 into the equation of the tangent line, it's going to give me y equal to 1 plus 1.099 times 0.1. And that's going to be roughly 1.11. If I go for the actual value, we're just sticking this into f. So f of 1, put that in here. 1.1 squared is 1.21 minus 1.1. That leaves me with a 0.11. 3 to the 0.11, I stick it into a calculator and I get 1.128. So these two are not so far from each other. So that's my actual value and my approximation. That's the whole point of having a tangent line. Let's look at another one. So I'm going to try g of x equal to log of x plus 1 to the base 2 at my same point 1, 1, and we'll also approximate the point 1.1. We could check again. If I put 1 in here, I have log base 2 of 2. That's going to cancel to give me a 1. So that is an actual point on our curve. Now, again, I'd rather tidy things up before I actually do any derivatives. So note that I can get rid of the base 2 here if I'm willing to divide by natural log of 2. Okay, that's a rule. You probably should have that memorized, and I kind of derived it in an earlier problem set. So I'm just going to take this as a function we know. Okay, this is a rule that we know. So the derivative is just going to be, take the derivative of the top. Okay, natural log of 2 is just a number, so I can just pull it out in front and not worry about it. So this is going to be derivative of natural log of x plus 1. I'm just going to take what's in here, put it in the bottom, and then derivative of the top is just 1. So this gives me my derivative. Now I want to put 1 in so I get the slope of the tangent line. That's going to give me 1 over 2 times natural log of 2. The exponent rule for natural log says that 2, which we could think of as being in front, can be brought to the exponent. So this gives me 1 over natural log of 2 squared, or natural log of 4. Equation of the tangent line is then y minus 1 equals 1 over natural log 4 times x minus 1. To get my approximation, I put 1.1 into the tangent line, and that's going to give me 1.072. The actual, which is just given by putting 1.1 into the actual function, that's going to be log 2 of 2.1. Okay, as I did before, I'm just going to do natural logs, and then that quotient gives me 1.0703. So again, we see these are pretty close.